Yeah.
Okay, great. So thanks for joining us for the second session. Yeah, today what we're going to go through is just we'll go through what we're trying to achieve with the mentorship program again, and then just the schedule. I've sort of adjusted the schedule, getting a bit more detail. You'll see that just now. And with session 2, we're going to do first an overview of the groundwater resource development process, then a feasibility review for groundwater development, geophysical surveys and borehole siting, borehole installation, construction and development, aquifer testing, borehole equipment selection, water sampling and interpretation of the results, groundwater management plans, and then water use licensing. And at the end, we'll have questions. Just to, as I was compiling this presentation, I saw like there's a lot of stuff that, if I shorten it, it loses value. So what I'm going to do, you'll see in the schedule, is I've split it into sort of today where we look at the process in general. And then next week, we'll go through the details of borehole design and aquifer testing. I hope that sort of manages expectations for today. And if anyone has questions during this, just stop me at the slide rather than waiting till the end, unless it's a general question, just because it is a bit technical today. So let's rather stop at the slide and we go from there. Okay, so the objective of the mentorship program is to provide an entry-level or a junior groundwater scientist just exposure and a bit of basic training that an internship would provide, just to give a stronger foundation to go forward into the industry and to give them a bit of background if they get their first job. It's not to provide detailed training or sort of a certified training. It's just to discuss it and sort of share my experiences and to grow each other, And the schedule, last week we had the introductory schedule, which will be up soon, like I said in the beginning. This one, we're going to do part 1 of the groundwater resource development process. Go through the process itself, feasibility, etc., like I said. Then part 2, I'd like to do on Tuesday next week. That'll be the more technical one. So it'll go through your drilling supervision, construction and design of the borehole, aquifer parameter determination and interpretation, and then your sustainable yield determination. The reason I want to split this is just so that we can dedicate some time to these things, because they are quite technical and I don't want to leave something out and give you half a story. So that'll be on Tuesday if everyone's happy with that. I'll send out an email and put it on LinkedIn as well later today or tomorrow. Then on the 23rd of July, next Thursday, we'll do groundwater characterization, what to look for and what's important at a site and when is it important. Then developing your conceptual model. And in August, we'll do groundwater modeling. And as we go and as we get feedback, we'll put more sessions and we'll sort of refine the sessions just so that everybody gets what they want out of this program. Okay, so this is the groundwater resource development process that I follow at Alicanto. This is something I've developed just through experience and through the legislation, the regulations. So it's not to say that this is the be-all and end-all and this is the way you have to do it, but it is based on best practices and sort of experience in the industry. The objective of any groundwater resource development project is to site, install, and develop an amount of boreholes. It could be 1, it could be 10, in order to meet the demand of whatever cubes per day. Every site will have an idea of how much water they need. So if your average borehole yield in an area is 0.5 liter a second and they need 1 liter a second, you'll need 2 boreholes, etc. But this is the basic requirement of any groundwater resource project. The development of your boreholes should be in alignment with the SANS 10299, which is the standards for groundwater resource development. That's the minimum. And then on top of that, you have to comply with the legal requirements such as the National Water Act and then any municipal bylaws that might exist. Yeah, I know Cape Town has some municipal bylaws specific to alternative water supplies such as boreholes or sort of reclamation and that kind of thing. So the first, we use the phased approach, which allows us to discuss with our client at the end of each phase. So if we need to stop a project or adapt the project, we only incur the costs of that phase. Yeah, that's what we went through in the last session, just to manage everybody's expectations and not get too deep into a project if it's not going to work. And phase one, we'll go through the data collection, review and analysis, which is your desktop review, your hydrocensus, and then a scoping or a feasibility report. And from there, we'll get the question, is groundwater development feasible? If it is, we'll go through to phase two, which is groundwater resource development. If it's not, we'll investigate alternative water sources and look at a water efficiency plan to meet the water demand. Yeah, that's what we can do at existing sites where we can look at grey water reclamation or water saving initiatives just to get that water requirement down to zero or to reduce it enough that they can look at cheaper alternatives. And in phase two, we do the geophysics if we can. That's an important question there. Can we do geophysics at the site? If not, we site it based on the desktop review and the hydrocensus data. If yes, we design and execute the geophysical survey. Then we go forward with borehole installation, aquifer testing, if it was successful, of course, and then your pump equipment selection and sustainable yield estimation. Something that's very important to get through to your clients when you're doing drilling for resources is that it might not be successful. Yeah, this is unfortunately, we can never guarantee water. And you know, anybody that does is unfortunately not telling the whole truth. And once we've done the aquifer yield, we go through to phase three, which will be your technical reporting. We do your groundwater reserve determination if you're doing a water use license, the groundwater management plan, and your technical report, which summarizes all of the different results for the preceding phases. So any questions so far? Nothing. Okay, so we'll carry on with the groundwater feasibility review. I just want to check if everyone's still here. Okay. I assume you guys are here, so I'm just going to carry on. With your feasibility review, so I just want to go back here. The main objective is to determine, are there sufficient groundwater resources at the site to be developed effectively and economically? Yeah, if you look at a site and there's no chance of drilling a successful borehole, there's no point in continuing. You're going to waste your client's money, you're going to waste your time, and it's just better for everyone not to do it. The way we do this feasibility without incurring too much of a cost is through a desktop review and then a hydrocensus investigation. The desktop review, it forms the basis of everything else we do. Yeah, everything we do from the desktop review onwards feeds back into this data. It gives us a good understanding of the setting and the potential of the environment during the project. And by the end of it, we should have a good understanding of all of your different environments that affect your groundwater, which would be your climate, your topography, geology, surface water or hydrology, and then of course your hydrogeological environment. Yeah, one of the, sorry, it just keeps, there we go. Can everybody see this table? Yeah, you can unmute yourselves and.
Yes, yes, I can see it.
Okay, great. Yeah, sorry, I just worried I was talking to myself there. So these you can see in this table on the far left, it's the environment, which one we're looking for, and then it's what type of data and information we get or look for. And then these are some of the common sources that you can use for, I'm not going to go through this in too much detail, but when I email this sort of PDF to you guys, you can go download all of the open source data that's there. Yeah, the important ones for me is this WR 2012 data. That gives you a nice overview of your rivers, your surface water features, your quaternary catchments, all of that data, and your expected aquifer types. So it will give you your aquifer yield. So it'll say intergranular aquifer with an expected yield of 0.5 to 2 liters a second, or the karstic aquifer. It'll give you a very good background information. And then the National Groundwater Archive, which is something we touched on last week. And it was raised that some of the data, or most of the data, is outdated. But if you take it for what it is and you filter the data, then it is useful. And I'll show you in the next couple of slides what to look for in that, and what it will give you from the National Groundwater Archive. And one more thing here, this world climate data is a nice data set. It gives you a grid view of all of the, it's like a ASCII grid of the world's average precipitation per month. You can get your January, February, so it's good to determine your distribution of rainfall. It is historical data, so it's 1970 to 2000. And then you can download sort of future predictive data from all of the different climate models for the globe. So if you're doing modeling and that kind of stuff, it is quite nice to get your rainfall data and do your recharge calculations for the next 60 years, I think it is. Okay, and then this is just how I present my desktop review in the reports. So your typical data sets you look at is your topographic maps, geological maps, hydrogeological maps. Your hydrogeological maps is pretty much what's in the WR 2012 data set in terms of aquifer potential. Aerial and satellite imagery is Google Earth imagery, and sometimes ortho photos if you're lucky enough to have it. Site climate data, NGA, regional water quality data sets from the RQIS data. Aerial geophysics, which is, sorry, I'm going to go back here. You can get that from the Council for Geoscience as well for South Africa. You've got the magnetics, gravity, total radiometrics, and that's those three. But you can download it from this website over here. And then from your client, they can give you the previous investigations, your monitoring, the layout plans, development plans and schedules, your water balance information, which will relate to your water demand. Your water demand is the most important thing for a resource development project, because if you don't know what you need to find, then you're just sort of poking in the dark. This is when you're reviewing your hydrogeological data specifically. The first step is to determine your potential aquifer types at the site. Your main types in South Africa would be fractured, intergranular, or dual porosity, which is a combination of fractured and intergranular, or a karstic aquifer in your dolomitic areas, such as the West Rand, or there at the Oog and those sort of places in the north. Then you got to look at your existing water uses, your catchment-specific management and or restrictions. That's where you've got your stressed aquifers where no abstraction is allowed at all. Because again, if you can't drill, then you may as well stop the project and tell the client, listen, you need to find something else. Then from your NGA data, you get your borehole and water strike depth information, which you interpret over here with a histogram. Does everybody know how to do a histogram in Excel?
Yes. Yes, thanks, Matthew.
Okay. So,
Yes, Matthew.
great, as long as we all know. So then you do this with your depth distributions. And you can see for this data set, I've got 3 distinct zones of water strikes. 2 general ones. If you look at this one at the top, that's probably a weathered water strike zone, where you've got your competent rock from 25 to 30 meters, and then from 35 to 80 meters is a fractured rock zone based on my geology for this site. So this gives you a nice overview of what to expect at your site. And then you can calculate your blow yields per zone. You can see the lowest zone here is your highest average blow yield. Does everybody understand what I'm saying here?
Now, may you please elaborate further on the blow yield?
Okay. So what I've done with the blow yields is I've taken, because from the National Groundwater Archive, you can get your water strike depths, your borehole depths, the blow yields recorded during drilling, all of that kind of data. So in the tables here, I've said zone 1 is where the water strike was less than 25 meters depth. So here upwards. And I calculate the minimum, all the quartiles, and then the average, just in Excel. And then zone 3 is everything below 60 meters. Every water strike below 60 meters, I've calculated the same, the quartiles and the average. And then zone 2 is everything in between. Because in the database, it says water strike depth, blow yield at that water strike. So I've just split it out there to see which is the highest yielding zone according to the regional data. Does it make sense?
Yes, thank you very much.
Okay. Great. Okay, so I'm just going to carry on then. So then you can look at your water levels as well. This is where the wheels fall off a little bit in the NGA, just because of their database structure. So you do have to be careful with filtering your water levels, because often you'll get it where you've got the same borehole, but it's recorded under different IDs or different sort of XY locations, just because their database doesn't allow duplicates. So look out for straight lines going up at a common surface elevation. Yeah, that's usually a bad data point. But once you've done that, you can do your statistical sort of correlation analysis of surface elevation versus your groundwater level. Just an XY scatter plot, and then you add a linear trend line, and you get your R squared. And in general, a correlation of more than 85% shows you that your groundwater flows under semi-confined conditions, and your groundwater levels mimic topography. So they're not exactly the same, but they generally mimic it. And then you can use Bayesian interpolation techniques to get your site groundwater levels. And if there's a low correlation, you'll see usually your groundwater levels will fall between a specific elevation range. And then you can look at your geology and you can determine, is it an unconfined aquifer or a confined aquifer? Yeah, unconfined aquifers, if you're near a river and you're in unconsolidated sand, it'll form like a swimming pool in that sand deposit. And then your confined aquifers, it'll be the same, but it'll be underneath your confining unit. So you just got to keep an eye on that. Your other important data is your groundwater quality and expected groundwater types. Groundwater types is your calcium bicarbonate waters, or those kind of things, calcium sulfate waters, and potential sources and sinks for groundwater in terms of quality and quantity. Is there a large abstraction program in your sort of catchment that you're drilling in? is there a big source? Are you next to a tailings dam? Are you next to a mining operation? You know, are there any threats to your groundwater source that you're drilling into? Then you've got to look for geophysical methods you can use, which we'll go through next. The expected drilling depths. Yeah, this is important from the NGA data. You know, when you know how deep your water strikes are, you can determine your drilling depth, because your drilling costs can range anywhere from 100 Rand to 1,000 Rand a meter. So you got to tell your client up front he's drilling 200 meters, or you know, just to avoid trouble at the end when you have to pay the invoice. Borehole yields at the site, that's to determine how many boreholes you need to drill and also what kind of aquifer testing you can do. And then the sensitivity of the environment to new developments. Yeah, is it a sensitive environment where if there's a new contaminant source, it'll destroy the groundwater system there? Yeah, like a karstic environment. If you dump sludge into the karst aquifer, that'll destroy the entire aquifer. And the hydrocensus, yeah, you have to identify all of the existing groundwater around the site. This is to get an idea of how productive the aquifer is, but it's also to see how close other groundwater features are to your site. This is important because if you drill too close to your neighbor's borehole, you might end up dewatering him or he'll dewater you, and then there could be quite a lot of issues, legal issues in terms of water access and those kind of things. Ideally, you want to do your hydrocensus within the model or your groundwater flow boundaries, which if you're doing a modeling exercise would be your model boundaries. But also if you just do a 2 to 5 kilometer radius, it should be fine. INAP is an interested and affected party. That is what we call sort of neighbors within a catchment. It's people that are interested in the project, people that could be affected by the project. So what we should get a list of INAP details from the managing EAP, the environmental practitioner, or the client. And then you phone the INAP before you go to site, just to make sure that they're there, make sure that they're expecting you and you're not there to steal their borehole pumps or whatever else they might think you're there to do. If you don't have these details, you need to take a letter with you saying why you need to do the hydrocensus, what you're doing the hydrocensus for, and then what kind of information you're going to collect during the hydrocensus. This is just to be transparent with the person who you're looking at their borehole, you're looking at their spring, just to make sure that you're not there to do anything suspicious. Yeah, people are quite touchy when you go to their site. Okay, and at each of the features that you go to, your boreholes, your springs, wells, etc., you're going to get the coordinates, the water level if you can, the equipment installed if you can, the details of the owner, just their name, address, and contact details for future reference. The general condition, you have to write down, is it a dirty borehole? Is it rusted? Is it sitting in the middle of a cow feeding field or something? And then take a photograph. We're quite lucky nowadays, we've got cameras on our phones. But you used to have to draw like a sketch and show contamination sources and those kind of things. At least now we can just take a photograph and it's done. And details on the equipment installed, that's if you got a base plate with the pump type, pump kilowatts. Is it a mono pump? Is it a submersible pump? And then if the person is willing to tell you, just the abstraction rates and what they use the water for. A lot of the time the people think that you're there to tax them on their water. So they're not going to be completely open about how much water they're actually pulling from the borehole. Is everybody with me so far for the feasibility side of it?
Yes, thank you.
Okay,
Yes.
great. Okay, then we'll carry on here. Just to your geophysics. So I'm going to go through this geophysics quite quickly because it's one of the technical things. But we'll touch again on it on Tuesday. Yeah, so just don't stress too much if I skim something. Make me aware of it, just so I can make a note of it. But I am going to go through it quite quickly. So the objective of a geophysical survey is to identify potentially groundwater bearing features within the underlying geology. Now, remember the word potentially groundwater bearing. You know, there is no geophysical method in existence at the moment that can tell you exactly how much water there is. You know, the geophysicists are working on it, but you must never tell a client that you found groundwater. Tell him that you found a drilling target, tell him that there's potential, but as far as I'm aware, and last time I spoke to the clever people that do the geophysics methods, there's nothing that can tell you there's 10 liters a second. So just be aware of that. And this picture, sorry, just to go back to it, this is from the Council of Geoscience. This is the open source data. This is the magnetic intensity map for South Africa. And it is quite useful just to get an idea of the orientation of structures at your site and all those kind of things. So I would recommend downloading it. Okay, some of the most important techniques that we use or get exposed to in exploration and groundwater exploration is gravitational methods. So gravity, which requires a contrast in earth material density. Magnetic methods, which require contrast in magnetic field properties of the materials. Electromagnetic methods, electrical methods, seismic methods, and then radioactivity methods. Now, seismic and radioactivity, I've personally never really been exposed to. You know, seismics you use more in like oil and gas exploration. So, you know, we learned it in varsity, but I don't think you have to concern yourself too much because I think it costs about R500,000 just to get the trucks out of the garage, you know, to go do a survey. So don't stress about those last two. Typically, we would use either EM34 magnetics or electrical resistivity, or a combination of these methods, which is something that was brought up last week, to use a combination. And in special cases where there's dolomite, we'll use gravity. But because the equipment is so sensitive, you typically get a contractor out to do it. You know, with the equipment, the spring, if the equipment tilts more than, I think it's 33 or 36 degrees, it snaps the spring. And then you've got to go send it back to Canada to get repaired. And it's just a big headache. So rather get the specialist to do it if you have to. Your references for this, if you can go look for it on Google and on Springer, if you have access to your university databases still, is Groundwater Geophysics by Kirsch, and then Molson Field Geophysics. Those are really good reading materials for you guys just to have a look at. Some of the important questions that you need to consider and answer when you're designing or choosing your method is: how big is the site? What's the dominant geology at the site? How deep is the aquifer unit at the site? Which is, how deep do I need to look for a target? Is there existing infrastructure at the site? So is there space to do the geophysics at the site? And is your client cost or time sensitive? And that's where this table here, so you can see with the big three, your minimum traverse length required. On magnetics, there's no limit, but less than 50 meters, you're not really getting useful data. Your EM34, you typically need more than 50 meters to do something useful because you do it at a 5-meter spacing. Electrical resistivity, because of the setup of res, you need at least 200 meters. So you're going to have a 100-meter cable either side of your reading unit. Then maximum penetration depth. Magnetics doesn't do penetration, it just reads the intrinsic earth properties. Then EM, 25 to 30 meters depending on your coil spacing. So with the EM, a rule of thumb is your penetration depth is about half of your coil spacing. So if you got your coils at a 40-meter spacing, you're looking at 20 to 25 meters. And then 10-meter coil spacing only looks at 5 meters. Electrical resistivity, your maximum depth that I've ever gotten on that with useful data is 200 meters, 180 to 200 meters. That's depending on your electrode spacings and the length of your traverse. You know, when we went to 180, that was a 1.4 kilometer traverse that we did. So it was quite long. And the sensitivity to infrastructure, yeah, your magnetics and your EM are very sensitive. If you're near a fence or an underground pipeline or a pylon or something, they jump around like no one's business. And you just get noise. And generally, your resistivity method is not that sensitive. Magnetics and EM are quite economic as a unit, the cost for the survey, but with EM, you need 2 people. There are 1-person EM methods out there, but I don't think they penetrate more than 10, 15 meters. So in South Africa, that's not really what you're looking for. And then electrical resistivity is the most expensive of these 3. Just a quick question for everyone. Have you, in varsity and that kind of things, did you get exposed to these methods, and are you sort of familiar with these, or should we go through them in a bit more detail next week?
Yeah, I did some electrical resistivity. I think we at my place, at my varsity, we did in detail about the interpretation, but I think we should go into detail about the how to operate them. I feel like it would be very useful.
Okay. Okay. Yeah, so look, then I'll make a note of that for Tuesday's session, and then we can go from there if everyone's happy with that. We won't do it today just to save time.
Okay, may we please also maybe next week look more into also how to interpret the data properly?
Yeah, no, look, definitely. We're going to go through it very quickly now,
Okay.
but we'll do the sort of operation and interpretation in detail on Tuesday. Okay, great. So just remember this table here for when you're designing your survey for a client. And when you're designing, you got to do your physical considerations. Can you get a drill rig into this area? Yeah, often, I mean, I had a guy, he spent about a week trying to do a survey on a cliff, just because I drew the line in the office. And, you know, he got back and there was no data on the thing. And I asked him where it was, and he said, no, it's on a cliff. You can't get a drill rig in there. And remember, at the end of the day, you're trying to drill a borehole for a client. So, yeah, what's the point? And then areas restricted clearance. If you can't raise the mast of your machine, don't go there. If you've got existing power services, power lines, water pipelines, don't go there because it'll interfere with your equipment. Areas of supporting foundations or underground structures. Yeah, this is something, if you know that there's an underground diesel tank, don't go drill there. Yeah, I've had one of my guys, one of the juniors, he drilled through an underground diesel tank. One of my competitors, one of the other consultants, they drilled through an underground jet fuel storage tank. Yeah, these things cost a lot of money. It's rehabilitation. It is. So if you know it's there, don't go near it. Don't even do geophysics there. And then areas with restrictions for installing your equipment. Environmental considerations you got to take into account. is if you get contaminated water, surface water running past the borehole, if it's in a sort of sluice where you get your runoff from industrial areas or something, it's not worth drilling there because all of that stuff will seep into your borehole. Areas where you got agricultural activity, such as your feeding areas, your dip tanks, wherever there's potential contamination, don't go near it. Areas where there's disposal of waste, areas with the buffer zone. So there are stipulated buffer zones within sort of wetland areas, river areas. You can't drill within 50 meters to 500 meters, depending on the sensitivity. So that goes back to your legislative requirements. Just be aware that you might not be able to drill there, even if there is a brilliant target. Rather just avoid it completely. And then your underground fuel storage tanks, etc. Don't even do geophysics at them because you're not going to drill there. So you're just wasting your time and the clients. And so just two examples very quickly. This site I did the combination of magnetics and EM, which is something that Condise brought up last week. So the reason I did both of them here was because we had a dolerite intrusion up at the top left here, which would give you your magnetic data. And then we had a contact zone between your Freiheit Formation and Royberg fault sites at the bottom, which the EM would have picked up quite nicely. Oops. You can see we pretty much ignored this area here because the client, initially the second pit was supposed to be here, but then they changed their mind. And we did magnetic lines here targeting your dolerite sill. And then we ran EM lines over there and over there. So line 2 and 5, we did EM and mag and 3A. We had to do 3A and 3B on the EM because they were busy doing their harvesting during the project. And then here is all of our targets that we selected. So we'll go through, this is line 5, which is over here on the eastern side of the property, going sort of north-south, targeting this dolerite sill. Okay, and you can see here going from south to north. You got this dip here. This is your Karoo, or sorry, from north to south. So this is where you go from your magnetic dolerite dike down onto your Karoo. Then you overlay the EM. We've got your horizontal dipole and your vertical dipole. You see these targets sort of correlate with one another. We'll go through this in detail on Tuesday, so I'm just going to skim it for now. You can see there, it sort of picks up. I'm just going to skip all of this, guys. Let's go through it in detail, otherwise I'm just going to confuse everyone. Is everybody happy with that?
Yes.
Okay, great. So I'm just going to skip through here. We'll do it on Tuesday. And we'll get to drilling. Again, we'll go through all of this in more detail. Typically, we use an air percussion drill, DTH downhole hammers. Other common methods is a cable tool, which is your stump boor. I've never used it personally, but I have seen them and I've seen the holes that they drill. And then we've got rotary drilling, which is also called mud rotary, or it's got a number of names. You can see there it drills with mud. So it's quite nice for your unconsolidated sediments because it gives you a little bit of stability on the outside of the hole. And you can use also symmetrics or Odex drilling, which is air percussion drilling with the casing being forced down the hole as you're drilling. I'll get some videos and stuff to include on Tuesday for us. And this table out of Driscoll, if you can get hold of a copy of Driscoll, the Groundwater and Wells, it's really it's a handy book to have. I think they are pretty well available on the internet. but if you can get it, I'd highly recommend it. We'll go through this on Tuesday. And then during the installation, your sort of main job as a hydrogeologist is to collect and maintain the following information. It's a pre-set up drilling rig checklists. That is the drill rig safe to operate? Are all of the pipes in working condition? Is the driller, does he have his PPE? Does he have correct qualifications? Is he sober? It sounds sad, but you do have to check all of these things. Daily site diaries, that is where you record how much meterage was drilled, what diameter it was drilled, who came to site, how much casing went down the hole, all of those things. A geological log of the borehole, the water strike depths and yields, and then your final blow yield of the borehole. And all of that goes into your drilling log, which is how you design your casing, and it helps to determine the efficiency of the borehole. So when you design your borehole, you need to consider the depth of the well screens or your screens, if you've got more than one zone of screening. In South Africa, we also refer to it as just slotted casing. So just to get the terminology there, if I talk about screens, it's the same as a slotted casing. So the diameter of your screening casing is important because you can't fit a 6-inch pump in a 6-inch casing. You need to have a bigger casing than your pump. And obviously your borehole needs to be bigger than your casing. So all of these things need to be taken into consideration. Your type of material for your casing, is it steel? Is it stainless steel? Is it PVC? In South Africa, we usually use either mild steel or PVC, typically PVC because it's cheaper. In your type of well screen, usually we use a mill slot, which is a machine slotted casing. And then your grade of filter pack, your formation stabilizer, that is in between the casing and the borehole wall, which we'll go through in detail. Like I said, I'm skimming through this stuff just to show you the process of resource development. And then I think on Tuesday, it's going to be better to focus on the three main aspects of geophysics, drilling and testing. Your casing needs to be strong enough to withstand your pressure. So as you go deeper, the ground will exert a lot of pressure on your casing. So if you've got thin walled casing, it'll collapse under the pressure of the surrounding formation. And it must also be strong enough or large enough to fit your pump. So if you've got a high yielding borehole, you need a bigger diameter to fit a bigger yielding pump. And your gravel pack, I'll go through the maths and calculating your gravel pack on Tuesday. But you put a gravel pack between your casing and the borehole wall to stabilize the formation so that the formation doesn't collapse on the casing, and also to act as a filter to get rid of sediment and sand entering the borehole. Your well screen, it's a balance between efficiency and also strength, because if you have a casing area that's open like 90%, it's going to be very weak. So you need to balance that out. And here you can see slotted PVC casing. This is a 165 mil. You can see there with 2 mil slots. I don't know if you guys have ever seen the casing before and you're sort of familiar with what it is there. Okay, and then development. There's a lot of ways you can do borehole development. You got your pumping, your surging, jetting, and then sometimes you do your disinfection, just adding your bleaches or chemicals into it. But typically we just do airlifting, where you just you lift the water out with the drill rods, compressed air. And your purpose is to remove all of the fines out of your gravel pack and to make sure that your slots are not bridged on the casing. You can see here, this is sort of a section of a Johnson screen where they've developed it. It just blows away all of the fine stuff so that your water is flowing through freely and efficiently. Is everybody okay with a general overview of the drilling process?
Yeah.
Yes.
sir.
Anything outstandingly obviously confusing in this?
Everything is still fine for now.
Okay, great. Okay, so aquifer testing, we'll just go through the types of tests. Yeah, the commonly applied ones that we use is a slug test or a falling head test, a step test, variable discharge rate test, constant discharge rate test, and then a recovery test. You can see here with the setup, you've got your pump and your pumping borehole, and then you put your discharge far away from your pumping borehole. Can anybody tell me why we do that?
So that you don't recharge the aquifer with the water you're pumping out.
There we go. I fell for that in my first pump test, and I wondered why there was a strong borehole in the middle of Mpumalanga. But yeah, I didn't connect the pipe properly. So I'm glad you guys know that. Yeah, and with your different types of tests, a slug test, you either add or remove a fixed volume of water to the borehole sort of instantaneously, and you measure the response. Variable discharge rate, you pump the borehole at a specific rate for 30 or 60 minutes, and then you increase the rate as you go on, and you measure the water level response. Constant discharge rate, you pump at a constant rate for anywhere between 6 hours and 72 hours. And recovery test is where you switch the pump off and you see how quickly the water level rebounds inside the aquifer, inside the borehole. Now, we'll go through each of these on Tuesday in detail because it's quite important, but it does take a lot of time. So what you need to take away from today is that you need to design your pump test based on what you need out of the pump test, out of the aquifer test. If you just need transmissivity values and aquifer parameters, a slug test or a step test will be fine. But if you need to design sustainable yields and sort of abstraction schedules, then you need to go step test, constant rate test, and a recovery test. Your recovery test is probably the most important out of your sustainable yield tests because it shows you how the water level rebounds. Because if you pump for 3 hours and it takes 5 days for the borehole to recover, it's not a sustainable borehole. Okay, and then your equipment selection, the type of pump that you choose, whether it's a submersible electrical pump, a windmill, a hand pump, you select based on the borehole depth, diameter, the yield of the borehole, total pumping head, which is from the pump inlet up to your discharge point, total pumping distance, which incorporates your friction loss in the pipes, and then what kind of sources you have for power, and then how long you're going to be pumping the borehole for. So all of this I'll go through in detail with everyone, but this is just to keep in the back of your mind for now. Then sampling, I'm not going to go through all of this, but the main things you need to incorporate in your sampling sheet is the name and location of the sample, when you sampled it, the date and the time, what you sampled from, was it a borehole, was it a well, was it a river, and then any descriptive information. Is the well a thin well, is it pumping at the time, those kind of things. Then your name, you need to put your name on the sheets, the COCs. I'm just going to go into Excel and show you what a COC in this looks like. I think it'll be easier. So just tell me if you can see. I'm going to just share my Excel screen. Okay, can everybody see Excel now?
Yes.
Yes, sir.
Okay, great. So this is your sampling record sheet. It will have your project name, project number, why you're sampling. Is it a hydrocensus? Is it routine monitoring? You know, those kind of things. Then your name. Is there storage available? You know, are you putting it in a cooler box? Are you just going to keep it in your bucky and run back to the hotel or wherever you're going to store? Yeah, then the laboratory, which laboratory you're using. ID, is it ground or surface water? Date of sampling, time, type of sample. That is it a grab sample? Is it a bailer? Is it from the pump? Is it from a tap? Yeah, what kind of sample is it? The water level, if it's a borehole. Depth of sampling. You know, sometimes you take specific depth samples. Sample preservation. Did you use acid to preserve the sample, or is it just an unpreserved sample? Field parameters, you measure with your hand probes. pH, EC, total dissolved solids. Weather conditions, is it sunny, is it cloudy? Yeah, just general observations. And then comments, just general comments. Is it a dirty borehole? Is the water brown? Does it smell funny? You know, all these kind of things. Anything that might add value to the lab analysis. Then this chain of custody is what you submit to the lab. And that it needs to include sample ID, date, time, and field parameters. And then very important here is your analysis required. So typically you'll get a quotation from the lab. You'll say, this is what I need analyzed. So it'll be according to, is it for drinking water? Because then it'll be the SANS 241 standards. Is it for irrigation? Because then it'll be the South African water quality guidelines. So that you need to incorporate there, because you're not always going to deal with the same lab technician that gave you your quotation. Okay. So can I go back to PowerPoint?
Yes.
Great. Okay, everybody see this again?
Yes.
Yes, sir.
Great. So in your groundwater sampling in general, if any contamination is seen, yeah, even if you suspect it, like if your finger slipped into the bottle or slipped onto the cap, just take another sample. Yeah, because if you, let's say your finger, you touch the bottle and then it picks up bacteria in the sample when there isn't actually bacteria, yeah, that can cost your client quite a bit of money. You wear disposable gloves, your nitrile or latex. And they're quite cheap, available from Dis-Chem. Personally, I prefer nitrile gloves because those don't, some people are allergic to latex, and also latex leaves a smell on your hand. As silly as it sounds, you know, but you don't want your hands stinking for the rest of the day. So nitrile gloves are the great ones. Use reusable equipment. You need to clean it. So you need to decontaminate your scoops or your syringes if you're reusing syringes. Your dip meter, if you've got a dirty borehole, just clean your dip meter quickly. The inner surfaces of your sample bottles and caps. If you can avoid it, do not touch it. Yeah, even just by accident, just don't touch it. Work with it like with kid gloves on, very carefully. In your samples, you should check for large particles such as leaves or any detritus that might be there. If you get that in your sample, just tip it out and take a new one. You know, sometimes you get it where you get a whole bunch of grass or something that's fallen in the borehole, or unfortunately, sometimes you get an animal that's fallen in there and it comes out in your sample bottle. Yeah, the lab is not going to be happy if you send that to them. So just tip it out and take it again. Your preservation techniques are in the Science 5667, but ask your lab. they'll always give you the sort of best way to go forward, because the lab techniques are evolving constantly, and unfortunately the science standards don't always keep up. So have a chat with your lab when you get the quotes. Ask them how to preserve it, what's going to be best. Because some labs want you to preserve it with acid, others don't. So just make sure that you're on the same page with your lab. Best practice according to the old sampling methods is that you take 2 samples, one that's filtered and preserved, and the other one that is just filtered. And then for microbiological, very important, in general you should get your samples to the lab as quick as possible. But for microbiological samples, where you're looking at bacteria and coliforms, etc., your holding time should be 6 to 24 hours. Ideally, within 12 hours, you should be at the lab. And your maximum, absolute maximum, is 2 days, 48 hours from sampling. This is just so that your results are accurate. And you should store these samples at 4 degrees. So just a cooler box with ice, but make sure that your sample bottles are covered by the ice. Is everybody sort of okay with what I've said here?
Yes, thank you.
Yes, thank you.
Cool. I'm just going through it very quickly, but yeah, as long as you're keeping up sort of. Then once you get your groundwater quality results, your groundwater quality not only gives you a good baseline indication of the overall quality, but you can also use it to get your aquifer recharge, your potential impacts and site activities, calibration targets for your modeling, identification of surface groundwater interaction if you have any at the site, your quality evolution over time if you've got monitoring data. That's showing if it's going from a bicarbonate water type to a sulfate water type because of your mining operations or something. And sometimes you can see potential sources of artificial recharge at a site, where you go from having a recharge value of 5%, and it increases steadily over time to 8%, 10%, because of leakage from your surface water infrastructure. I'll show you an example of that next week. I've got quite a nice one that I did a few years ago. And this is how can everybody see this table?
Yes.
Okay, because I had to sort of squish it in. But, this is how we present our water quality information in the report, where you've got your parameter, the units, and then your different standards. So we've got the Science 241 limit, which is for drinking water, your water quality guideline target range for domestic use, which is also drinking water, and then your agriculture irrigation target range. So you can see I've got the different colors, and then I've colored in my sample results here with different colors. So red exceeds your Science 241, you can see there. Orange is domestic use, and then green is your irrigation use. So it just gives you like a straightforward, this is how compliant or non-compliant it is. Yeah, and this you just do manually. You can do conditional formatting if you really want to in Excel, but that takes longer than actually just doing it yourself. But you can see immediately from this what's compliant and where the issues lie. Then a Piper diagram. Did you guys do Piper diagrams in university?
Yes.
Yes, sir.
Okay, great.
Yes.
So good. So it's not totally foreign. So your Piper diagram is the best way to describe the dominant water at a site, your water type. You've got your cations on the left triangle, anions on the right triangle, which plots in this diamond area here, which determines your dominant water type at the site. It shows your different water sources based on their chemical signature. And this is one of the ways you can determine if there's surface groundwater interaction at a site. If you've got sort of chloride type borehole, chloride type surface water, and everything else is a different type, then you can say they're interacting most likely. And also what we see on some of the mines is it'll go from a bicarbonate type anion up to a sulfate type as acid mine drainage develops. You know, as the stuff starts degrading and generating acid. And a good Piper diagram software free one is the groundwater chart or GW chart from the USGS. It's fairly straightforward, easy to use. It gives nice data as well. Yeah, there are a lot of spreadsheets available as well, but they're quite complicated and they're also in American units, which don't always make sense to us. I don't know if you guys know of any other sort of open source software that does Pipers and Stiffs and Durovs.
I believe Dr. Dennis from the Northwest University has Aquiworks that you can also use.
Is that open source?
I believe so. It was for free download on the water science website. On their website. I believe you can just check with him if it's still open source.
Yeah. Okay, no, I'll check that out. Thanks. And have you worked with it?
Yeah, we did it in my honors year. We used it a couple of times.
Okay.
You can also use this website, Golden Software. Use a Grapha software there.
I think Grapha is proprietary, isn't it? Isn't it quite expensive?
I'm not sure about the price, but you can download the software from there and then try working with it.
Okay. No, thanks. We'll have a look. Okay, so that's Pipers. And then the chloride mass balance method, that gives us quite a good indication of your recharge at an area. So the equation is your recharge is equal to the chloride in rainfall plus the dry deposition of chloride, which is usually 10% of rainfall chloride, multiplied by the precipitation, divided by your groundwater chloride concentration. Has anybody used this before?
Yes.
Yeah.
Okay. And like the biggest challenge with this is getting your rainfall chloride. Yeah, that for me at least, it was always quite a big challenge. But there's a nice paper by Eddie van Wyk and Dani Vermeulen from Free State that sort of goes through. I'll share it on when I send out the PDFs and that tomorrow or Saturday. But it goes through the rainfall cycles and it shows you peak rainfall chloride concentrations for across South Africa. So that's quite nice. I don't know if you guys know any other sources where you can get the rainfall chemistry data. Nothing. Okay, and the last section we're going to go through is just the management plan. I'm just going to mute you here, Kundisi. Okay, you need to include the following in your management plan. It's a description of the management philosophies, your management strategies, performance objectives, an analysis of the available management options and the motivation for implementation, short, medium, and long-term action plan, and then your control and monitoring measures at the site. Now, I'm going through this quickly because we did it last time, but now this week I've included an example of a management plan just from an actual project. So your objectives of the management plan and then your general approach. The general approach has the key principles to minimize the loss of groundwater resources through effective monitoring and management of groundwater abstraction, and then your measurement, monitoring, evaluation, and updating of management measures continuously throughout the life of mine. So everything is adaptable. Everything is, your management measures change. You might go through a drought year, so then you need to manage it more. You might go through a flood year, so you need to manage it less. Always leave sort of a bit of leeway, because there's no point doing overkill or underdoing it with no option to change it. And this is the management controls for the actual borehole. So the borehole goes to a depth of 120 meters with the main water strike at 105 with a static water level of 13. That gives you an allowable drawdown or an available drawdown of 91 meters, which is 105 minus 13.2. And then when we calculated the sustainable yield, we used 80 meters to be conservative. Sustainable yield for 24 hours was 2.5, where we recommended 12 hours per day pumping at 3.5 liters a second. That allows 12 hours pumping, 12 hours recovery. And then we just listed recommended abstraction rate, running time. You see, we just simplified everything that's up here into bullet points. Water levels to be measured weekly and stored in a central database. Flow meter at the borehole, measured weekly and stored in a central database. Detailed water balance to manage your water usage and identify your areas for reuse and water saving. And this is an important one. If your abstraction is proven to affect your neighbor, which you've identified in the hydrocensus, then you're going to have to pay for him to get a new borehole if they can prove that you've done it. This is important for the mines because they do unfortunately dewater people, but so do private people. I've seen farmers where farmer 1 drills to 100 meters and then farmer 2 drills next door on his side of the fence to 120 meters and pulls all the water. So you just got to include that in your management plan to make sure people behave and follow it. And then your monitoring results should be interpreted biannually by a qualified hydrogeologist and the network audited annually to ensure compliance. That's just to make sure that your monitoring network actually covers the extent of what you're monitoring. Is it too big? Is it too small? You need to adapt it accordingly. Okay, your monitoring network. I'm just going to skim this very quickly. We'll go through this in another presentation. So you want to monitor your rainfall, your abstraction volumes at the production boreholes, measurements of your groundwater levels at each of the boreholes, and then water quality sampling. Depending on how sensitive your water quality is and how much contamination sources there are, that typically goes from monthly sampling at active mining sites or active industrial sites where there's a lot of potential for contamination, up to quarterly for most sites, and then sometimes biannually or annually. I prefer biannually because then you take a summer sample and a winter sample where there's not that many contamination sources, but you just need to make sure that nothing has entered your water sources. Okay, and then depending on the volume of your water that's required, you might need either a general authorization or a full license. This is something you need to make your clients aware of. A Schedule 1 use is a small amount of water. So that's for your domestic use. Like if you just drill a borehole for your personal household, then that's a Schedule 1. Existing lawful use is where you were registered before 1998. You just have to sort of redeclare your water use. General authorization is where you're abstracting an amount less than the general authorization amount, which I'll show you now. And then a water use license is where you abstract a volume over the general authorization amount. So Water Affairs needs to tell you yes or no, you can abstract or you can't abstract. Then here is the general authorization yield amounts for South Africa. You can see in the red, it's where 0. That's most of the Northern Cape, a little bit of your stressed areas in the Western Cape, Eastern Cape, and then a little bit of Gauteng, Limpopo in this area here. So this is where anything you want to abstract, you need to get a water use license. And then it goes up to 400 in this Northern Natal, a little bit there, Eastern and Western Capes. Yeah, this is meters cubed per hectare per annum, which sounds like a lot, but if you've got a 1 hectare property, that's 400 cubic meters per annum, which is 400,000 liters per year. So it's not actually that much. You consider your average household uses about 36,000 liters a month. So you're going to just squeak into it if you're 2 people in a household. Is there any questions for today or anything you want specifically for next week?
Oh, yes, sir. My question is from the previous slide that you just skipped about that map. You are saying that which one needs the license? Is it the general water general authorization, or the one in highlighted in red?
Okay.
Sort of.
So the way it works is you get a general authorization, which is where you don't need a water use license. You don't need to do a full study to sort of license your borehole with water affairs. You do a general authorization application where you just say, I am abstracting this much, which is below the general authorization limit as stipulated by government regulation X. So you can see in red, the general authorization limit is 0. So any abstraction, doesn't matter how small or big it is, needs to have a water use license. Whereas in the purple areas, your general authorization limit is 75 meters cubed per hectare per annum. So if I've got a 10 hectare property, I'm allowed to abstract 750 cubic meters of water per annum without a water use license. Anything above that needs a water use license. That makes sense.
Okay, no, thanks. I just wanted to ask, is this information available on the government database, or the whole map?
No, the map I've done myself. I can share it with everyone. Let me just make a note of it. Now, I just made this map myself, but all of this information is it's one of the government, the GNRs, government notice. It is gazetted and it is official. So when I share it with everyone, I'll post it on LinkedIn or something, and you can download it. But I've just done this per catchment because the general authorization limit is specified per quaternary catchment.
All right, no, thanks.
Great. Any other questions from today's stuff, guys?
Matthew, regarding Tuesday, is it possible we can move it on an hour?
So do you want to start it at 5 o'clock or 3 o'clock?
5 o'clock if possible.
Okay. Anybody have an issue with that?
No, that's fine for me.
Okay.
It's fine for me too. 5 o'clock.
Yeah, I think it's okay. Yeah.
Okay, great. So then I'll post it tomorrow. We'll just make it 5 o'clock on Tuesday.
Thanks.
No
Matthew,
worries.
I have a question.
Mm-hmm.
I want to ask, let's say like you are a recent graduate, right? And then you're looking into starting your own consulting firm, right?
Mm-hmm. Mm-hmm.
How does it go on about when charging for a geophysical survey? Like, what factors do you look at?
Well, look, when you sort of designing it, you're going to look at how much geophysics you're going to do. You work on an average of 800 meters a day. Okay, that's how much you can do with EM, mag, and resistivity. Yeah, that's sort of the average. So you look at that. So let's say you've got a 3.6 kilometer or 3.2 kilometer survey that you need to do. That's going to be 4 days. So then you know it's going to take you 4 days. So then you're going to take your professional rate that you're charging for 4 days, and then your equipment rental rate for 4 days, and your travel costs and all those kind of things. You know, you work out your travel cost with the AA rate for your vehicle and your accommodation and subsistence cost as well. So that's sort of the cost you need to take into consideration.
Okay, thank you very much.
Does it make sense?
Yes, it does.
Okay.
And then do you charge per survey, or like when you conduct a geophysical survey, do you conduct using all three methods, or do you charge per survey that you use?
Well, typically in consulting, we charge for our time. So you're going to have three elements to your proposal, to your quote. You're going to have your professional fees, which is your time. Then you're going to have disbursements, which is travel, accommodation, food, and subsistence. And then you're going to have external costs, which is your equipment rental, your laboratory fees, your drilling contractors, those kind of things. So you're going to charge, if it's going to take you 5 days to do EM, you're going to charge the 5 days of your professional time, your travel time, and then the EM equipment rental charges. And if you're doing it with all three, it's going to be 15 days or 10 days if you're using EM and mag. And then you're going to charge for the equipment rental for those 2 pieces of equipment, or the res, so your 3 pieces of equipment.
Okay, thank you very much. And then in next week's session, would you mind telling us which softwares to use for interpreting the res data and getting the res data?
Yeah, no problem. I can show you the one that I've used is res 2D in INV. That's the one, but like I get the contractor, to be honest, I get the contractor to do it. Just because he's got the software, he's got the fully licensed software, and to buy the software is not worth it for me because I use it maybe twice a year. Okay, so I'll prepare some examples, but it'll be like on trial or sort of because you can download it for free, but it's just limited as to how many iterations it can do. So I'll go through it with you, no problem.
Thank you very much.
Matthew, I just have a question regarding aquifer tests. Sometimes people use the blow yield to determine the rate of the first step in a step test.
Mm-hmm.
Is there a standard method to determine the blow yield while drilling?
Well, there's 2 sort of accepted ones. The first one that is the one that's most commonly used is just a pipe in a bucket method, where you make like a dam around the head of the borehole, and they blow, and then you measure how long it takes to fill the bucket.
Okay.
Or you get a V-notch.
Okay.
I don't know if you've ever seen a V-notch before.
Yes, yeah.
Okay, yeah, so you get your, I think it's a 60 or a 90 degree V-notch. So those are the 2 accepted ones.
Okay.
Yeah, and then for the step test, you take the first step is usually 30% of the blow yield. And then it goes 50, 75, 100, 110, depending on your results.
Okay. But we'll cover that next week, maybe in detail.
No, definitely.
How to determine. Okay.
Definitely we'll go through. Yeah, like I said, I didn't want to go into it now because I think I would leave stuff out in the interest of time. Yeah, so I'd rather dedicate some time to it and do it properly.
Okay. No, that's fine. Thank you very much.
Yeah, great.
Matthew, will your slides be available like via PDF or something, or this recording?
Yes. Yeah, what I'm gonna do, like this week, I think I'll be able to upload it quicker to YouTube. I'm gonna upload last week's session and this week's session to YouTube, and then I'll put the PDFs, I'll email it to everyone, but I'll also put it on my company website just for download.
Okay.
Oh, thanks a lot.
Yeah, I'm just, like I said to everyone last week, I'm new to this whole social media thing, so I'm just trying to figure it out as I go along.
Yeah, you are doing great.
Thanks, Patrick.
Excuse me, hello.
Yes.
Please, next week, 5 to what? 5 to which time?
Look, I'd say we make it another hour-and-a-half session. Otherwise, we can make it 5 till 6 and then do another one on, we can do Wednesday as well.
Okay.
Yeah, what's going to suit you guys best? Do you want to do 1 2-hour session, or do you want to break it into 2 1-hour sessions?
I think if we break it down, that is better.
Yeah, I think it's good to break it down.
Okay. Then what I'm going to do tonight then is I'll just put up like a poll on LinkedIn maybe. And then we can see what everybody wants to do. Maybe we do Monday, Tuesday, Wednesday. Like we do quite a few sessions next week. We dedicate an hour to each segment. Then we can do a bit more practical stuff.
Okay, that sounds perfect.
That's fine.
Okay, great. Yeah,
That's okay.
then I can email some data sets and we can work through it together maybe. That might be a good idea.
Yes, I would like that.
Okay.
Okay, great. So just keep an eye on the LinkedIn page. I'll just put up that poll and I'll just make it so that we vote up until Saturday, if everybody's fine with that.
Yes.
Yes, that's fine.
Great stuff.
Yeah, that's fine.
Okay. Is there any other questions? Nothing. Okay, then I think let's call it for today, guys. Thank you for coming again. I hope it helped give you a good overview of sort of the general process of groundwater resource development. And I look forward to seeing you guys again on Monday or Tuesday next week. We'll see what's happening on LinkedIn and we'll go from there.
Thank you, Matthew.
Thanks.
Thank you.
Thanks, guys. Have a good weekend.
Thanks, Matthew.
Thank you very much.
Thanks. Cheers there.